In this video, we'll be demonstrating the use of a deadweight tester to calibrate a Bordon pressure gauge. The deadweight tester consists of an oil-filled reservoir, a pressurizing pump, the test gauge, and the piston. The piston is where the calibration weights are placed to pressurize the system and calibrate the test gauge. In this experimental setup, we have two different sizes of test weights. The large weight is the equivalent of 20 psi, and the small weight is the equivalent of 5 psi. There are 4 of each of these weights, which allow us to calibrate in 5 psi increments a calibration curve from 0 to 100 psi. In this example, we will be calibrating the pressure gauge to the equivalent of 45 psi. To do this, we first place the calibration weights on top of the piston. So for 45 psi, we will have 2 large weights and 1 small weight. The pressure relief valve then needs to be closed to pressurize the system. Once the relief valve is closed, we can pump the system and increase the pressure on the pressure gauge. As the pressure increases, you will notice that the gauge needle starts to rise. Continue pumping until the piston lifts the dead weights off its seat. Once this has happened, we've reached the point where the calibration weights are exerting exactly 45 psi on the oil in the system. The pressure can now be read off the gauge and used in your calibration curve. This process can now be repeated for all the calibration points listed in the lab manual. To do this, the pressure relief valve is opened to reduce the pressure in the system. Calibration weights can then be removed or added to whatever is required for the next calibration point. The process is then repeated and pressurized, and the next value is then recorded, thereby completing the calibration for the gauge, which can then be used in the field.